Hello and welcome back everybody to Aviatrix Deep Dive with Saad. Today's session is a follow-up session on ActiveMesh technology, where we will be discussing a very important topic called active standby running on ActiveMesh Aviatrix gateways. In the previous session, we discussed a lot of goodness of the ActiveMesh, so why we need to run the active standby on Aviatrix ActiveMesh gateways. There are some scenarios where enterprises can utilize this active standby functionality, and I'm going to discuss that. The most important use case is where remote devices doesn't support asymmetric routing. For example, firewalls. So let's draw it out so we have a better understanding of it. So in the architecture where we have Aviatrix spokes, let's say this is Aviatrix spoke 1, and we have Aviatrix spoke 2. Could be a VPC, VNet, or VCN, and we have Aviatrix spoke gateways, and we do have Aviatrix transit gateways. Since this one is running ActiveMesh, then we have multiple tunnels from each spoke gateways towards each transit gateway, the way I'm drawing it right now. And same thing is true for spoke 1 as well. So the northbound, or whatever you have in the cloud, everything is running the ActiveMesh technology. Now, if I'm going to draw an on-prem environment where we have a firewall, and you are connecting your on-prem to the cloud using a firewall like an IPsec connection. So your connection is going to be something like this. So what is going to happen at this point if you are sending traffic in northbound direction or southbound direction? It basically does not matter. But just let's take a look at it right now. If you have some applications trying to get and some applications in the cloud. So traffic here gets to the transit. It can go to the primary transit or to the HA transit and get to the spoke 1 over here. Now the return traffic could land to a different transit and get to the firewall on a different interface. When firewall is going to see the traffic on a different interface, then firewall is going to consider that traffic as an asymmetric traffic because it receives the traffic on a different interface. So let's draw it out. So let's say the traffic comes to the transit, gets to the spoke, and gets to the application. Application returns the traffic, but the return traffic actually, instead of going to the primary transit, it goes to the HA transit because there is always ActiveMesh running and it's always getting ECMP'd. So now the firewall is going to receive the traffic on a different interface. When firewall receives traffic like that, then it's going to raise the flag and it's going to call it as an asymmetric and drop all the traffic. So this is a very important use case for the enterprises, which is going to connect the cloud to the on-prem using the firewalls, and that is going to create the issues. Now, what can we do in these kind of scenarios? So alright, so when we enable this functionality, we are going to call the primary transit as an active transit, and then the HA transit as a standby transit. Now, only one tunnel is going to be active at a point, and which is going to be towards the active transit. So this tunnel, which you are saying, I'm going to just mark it as the standby tunnel now, right? So this becomes in standby. So the traffic now originate from the data center, gets to the spoke, and then the spoke might send the traffic over to this standby transit, or from the ActiveMesh perspective to the HA transit. But instead of sending the traffic over to the standby link, it is going to utilize its internal link between these two transit gateways and send the traffic over here. Now the primary transit is going to receive the traffic and then sends the traffic back. So now firewall, when it's received the return traffic, it's going to receive the traffic on the same interface where it departed. So this way the firewall is not going to complain anything, and it's going to be considered as a symmetric flow, and everything is going to be fine. Let's talk about a little bit more details how you can completely utilize this functionality. Aviatrix controller is going to take care of everything in the cloud on the transit gateways. It's going to make sure that the primary gateway is going to be active, and then the HA gateway is going to act as a standby using its metric values. Like the routes that is received, it's going to manipulate the metrics over there. But what about the on-prem, on your firewalls? You want to make sure there are still two links, two connections, one going towards the active transit gateway, the second one goes towards the HA transit gateway. You want to make sure that none of the traffic is going to be forwarded on this standby link by using technology like local pref or whatever make the path towards the primary gateway less preferred. Basically, you need to take care of this thing in the northbound direction. Now, one question that could arise, hey, why don't Aviatrix controller start prepending the AS path from the HA gateway so nothing could be done on the firewall side? From the Aviatrix perspective, at this point, we consider the connection to the on-prem, which we call it a site-to-cloud connection, as a single connection. So if we are going to prepend the AS path, then it's going to be prepended on both links over here. Okay, so now let's discuss more details. If you have a requirement to have something like this where your devices are the firewalls in the on-prem environment and you are connecting to your cloud environment like that, and you need to enable the active standby on the transit gateways like here. In this scenario, just remember this active standby knob is a global knob. So if you enable this thing, it is going to be enabled for all your connections, all BGP connections, and also all static remote route-based connections. So it is a global setting. ActiveMesh between the spoke and transit, like the way I'm showing in the cloud, is not going to get impacted with this thing. That would remain ActiveMesh, while only the southbound is going to be active standby. There are two different modes when you enable the active standby. Then you have a choice of enabling two different modes. The first mode is preemptive and the second one is non-preemptive. By default, Aviatrix enable this functionality in non-preemptive mode. So what is a preemptive mode and non-preemptive mode? Your primary transit is an active gateway. At that point, when all the tunnels to the primary transit gateway goes down, then it will switch the gateway from standby over to the active gateway. What is going to happen when some tunnels or all the tunnels comes back up on the primary gateway? Is it going to switch this behavior back to the primary gateway and make it active again? That depends on the knob or the selection which you are going to make when you enable the active standby functionality. If you make it as a preemptive, then that switchover is going to happen, but remember, it is going to disturb your traffic. By default, Aviatrix controller keeps this set. When you enable this setting, then it's going to keep it as non-preemptive. You also have an option. If you keep it as a default, which is a non-preemptive, then you can forcefully switch over the traffic from a standby to active, and then there's a knob available for you. So this functionality is available on Transit Gateway as well as BGP on Spoke gateways. So there are two different types of Spoke gateways. We are going to talk about this thing in the upcoming sessions as well. The other is the regular Spoke gateways, and then there are some Spoke gateways on which you can enable BGP. So we call those gateways as BGP on Spoke gateways. When you enable the active standby on the Transit gateways or BGP on Spoke gateways, then the functionality is for a single remote device. And we understand that the majority of the enterprises have the resiliency even for the on-prem devices as well. So by the way you do this thing is to create a couple of connections. So first connection is with the first device, and then the second connection is with the second device for your on-prem environment. So basically you have to create two connections at that point. So let's talk about it. What do I mean by that? The two different types of connections. So if I'm going to just draw the transit here. You have transit primary, transit HA, a connection between them. And then you have an on-prem environment where there is your active firewall. Let's say this one is your active firewall. You have a tunnel with the active transit, and this becomes your standby, while the other tunnel is going to be a standby. And that becomes your connection 1. Your connection 2 is with your standby firewall. Again, two transit gateways, link between them. This will stays as active. This one is your standby. The firewall over here this is your standby firewall. Okay. And then we have two connections over here, connection 1, and this one is a connection 2. So if we talk about the connection number 1 from transit to active firewall, the connection, the second connection will automatically have higher metric on the HA gateway. This is something done by Aviatrix controller. And we are not going to use this connection unless all the active tunnel goes down and we are going to switch the active from the primary transit gateway over to the secondary or the HA transit gateway. While on the second connection from transit to standby, the tunnels are going to be up, like both tunnels are going to be up, but since the firewall is in standby, we are not going to receive any traffic, and we are not going to actually send any traffic over here also. So everything is going to be totally fine in this scenario. All right, so if I am going to combine these two connections in one, how it's going to look like, let's do that. All right, so this one becomes your connection number 1, and this is your active connection. This guy is your, again, connection 1, but this is a standby. This one is connection 2, active, but again, since firewall is in a standby, we are not going to utilize this. This one is connection 2 and that is in standby. So that is how, if we combine both connections, this is how you are going to see it. All right, so let's talk about when your remote devices are routers and you would like to use some primary backup scenario. For example, one of your link is a 10 gig link while the other link is a 2 gig link. How are you going to utilize this ActiveMesh standby? All right, so let's draw it out. You have some spokes. I'm just going to draw one. And then you have transit. Let's say there's already an ActiveMesh connection. Transit over here. And then on-prem, let's say you have two different routers. R1 and then R2. Let's say these are your WAN routers and there are two different types of circuits are connected. So the first one, we have 10 gig. The second one, we have a 2 gig connections. And definitely, as you can see, you wanted to prefer the 10 gig over the 2 gig. Right? In this scenario, one thing we need to remember that we really don't need to enable the ActiveMesh standby on the transit gateway. The ActiveMesh standby is going to be for the on-prem environment, but we are going to support that, right? So from the Aviatrix controller perspective, you need to create only one connection with the remote gateway HA knob in there. So tunnels will be up from both Aviatrix gateways towards the both R1 and R2. And then, but standby router, which is router number 2, will be sending the prefixes with the longer AS path. So basically, you need to do some AS path prepending on the R2 side. So Aviatrix Transit Gateway are never going to prefer that route. Let's take a look at how the tunnels are going to be formed and which one we are going to prefer. So from R1 perspective, so this is going to go like this, and then we are going to utilize the 10 gig link and then the HA gateway. While the R2 is going to create the connections like this, but since we are prepending the AS path over here, Aviatrix transit gateways are not going to prefer that 2 gig link unless the link goes down. One difference between the previous scenario and this scenario is the R1 is not a firewall. It is a router, and symmetry is not going to be an issue for a router. So even though the traffic can come from the other interface on the R1, it is not going to drop those packets. So even the asymmetrical traffic is totally fine. So on the R2 perspective, you need to prepend the AS path here. All right, so the next architecture for ActiveMesh standby clustered firewalls. At this point, you need to create a single site-to-cloud connections from Aviatrix controller without the remote gateway HA, as I'm showing you on the screen. But provide both remote firewalls tunnel IPs and enable the ActiveMesh standby knob. You have already enabled the ActiveMesh standby functionality on the Aviatrix Transit Gateway, but at this point for local tunnel IPs and remote tunnel IPs, make sure you provide both 169.255 addresses for both firewalls with the comma separation in there, as I'm showing you on the screen, for local tunnel IPs and remote tunnel IPs. So only one firewall is going to be active at a time, and the firewall IP stays the same after the failover. So it should not be an issue. So that's how you are going to create the connection for ActiveMesh standby clustered firewalls. So far we have discussed different scenarios and designs using the active standby functionality. Then let's talk about the failover scenarios. All right, so if you have a clustered firewall, for example, cluster active standby firewall over here, and then Aviatrix gateways. Let's say this is your primary transit gateway, and this is your HA transit gateway. Primary is your active, HA is your standby. There is a connection between them. From the active standby firewalls, the connection is something like this. Towards the primary, it's an active link, and this becomes your standby link. Aviatrix controller is going to manipulate the metrics of the routes that is received on the primary or the HA gateway, which basically are the active and standby gateways in this scenario. So on the primary side, the metric is going to be 100 when you're receiving the routes like this. On the secondary side or standby side, you are going to see the metric of much higher metric, like 300 in this scenario. Primary is going to advertise the same routes which it's received from the active standby firewall, which is the clustered in this scenario, in this direction as a 125 with a metric of 125. While HA is going to advertise the routes that are received from the clustered firewalls over here with a metric of 325. So as you can see, these are much higher metrics from HA gateway towards the primary gateway. So primary gateway is never going to prefer the routes coming from the HA or standby gateway in this scenario. Let's talk about the failover scenario. So when failover doesn't happen unless all the tunnels to the active gateway are down. When all the tunnel goes down, then the controller is going to switch over the active from the primary over to the HA. Now, what happens when this tunnel comes back on to the primary gateway? The switch over depends if your preemptive settings is set to either preemptive or non-preemptive. If it is set to preemptive, then what controller is going to do is going to switch over the active from HA gateway over to the primary gateway one more time. But just remember, this is a disruptive process. By default, Aviatrix controller, when you enable the active standby, this setting is preemptive, non-preemptive in nature. So let's say if you start with non-preemptive, which is a default method, and when this switchover happens, like you lose all your connections to the primary and the controller switch it over to the HA gateway, now the HA becomes the active. At this point, all tunnels comes back, or some tunnels comes back over to the primary. Now this time, if you want to switch over your active gateway from HA towards the primary, then you still have an option. There is a knob available in the controller which is going to let you manually switch over your active from HA over to the primary. It's up to you at this point, but again, remember, this is a disruptive process. So far we discussed the active standby. So what are the metric values when our architecture is based on the ActiveMesh technology, like by default? So in the same scenario, if I'm going to just change few things over here, since there is no active standby, everything's ActiveMesh, which basically means both gateways are active at the same time and both tunnels are active also. So our metric towards the primary and then the HA gateway are going to be same, which is 100 on both sides. And primary is going to advertise these routes which is received from the on-prem device with the metric of 200 towards the HA, and HA is going to do the same thing like use the metric of 200 towards the primary gateway. So once you enable the activist standby on ActiveMesh gateways, then the metric is going to change from, let's say it was 200 before, then it's going to change it to 100. Okay, so that's all I have for activist standby. Thank you very much for watching. I'll see you in the next session.